Okay, we are going to work on solving equations with variables on both sides of the equal sign. So this is very similar to multi-step and two-step equations. We'll still be doing inverse operation. However, the first thing that we'll have to do with the majority of these equations is move one of the variables from one side of the equal sign over to the other variable on the other side of the equal sign. So a helpful hint when doing this is to identify your variable, which is your linear term, and where they're located. Are they both on the same side? Are they on opposite sides? That's what we need to determine. So we're going to look at this first example. 5x plus 13 equals 2x plus 22. So the first thing that we need to do is we need to identify where our linear terms, those are the terms that have the coefficients in front of the x. These here are called linear terms if you want to label that in your notes. These terms here, the 22 and the 13, those are your constant. There's your constant terms because they're always 13, they're always 22, they stay constant. Whereas this one, 2x, and this one, 5x, called your linear terms, these are not constant because they will change depending on the value of x that you put in. So what I'm going to do is, I know this 5x and this 2x, those are my two linear terms in this problem. And make note that they are on opposite sides of this equal sign. So my suggestion whenever you're solving a problem like this is to actually move or identify the smallest variable, the smallest coefficient, and move it to the larger coefficient. And the reason why I suggest doing that is just because that'll help later on with more difficult equations to eliminate having to deal with negatives very often. So if I look at this problem, I have a 2 in front of this x and I have a 5 in front of this x, so clearly my 2 is my smaller variable. So this is considered a positive 2x, and we want to move this term that I've highlighted here in pink all at once. Don't try to break it apart by dividing by 2. You want to move the 2 and the x as one term together. So since this is a positive, understood positive 2x, the inverse of that would be a negative 2x. And remember, what we do to one side of our equal sign, we have to go over here and do the same thing to the other side. Now, if you've highlighted your constant terms here, then you know exactly where to subtract your 2x from. So make sure you've got that lined up perfectly there. So 5x minus 2x, that gives us 3x. 5 minus 2 is 3. Plus 13, I have to carry that down, very important, equals. Now on the right hand side of the equal sign, this does become 0. 2 minus 2 gives us 0. That was the point of that problem. And we have a positive 22 left on this side. So once you've moved your variables over, you're now down to a two-step equation. So we're back to where we have been previously in other videos. So now let's just look at what we need to do. We have two steps. So identify what is happening with your variable. First, we are multiplying by 3, and then we are adding 13. So we've discussed in the other videos, in order to remove the number, the coefficient, and this constant, we have to use inverse operations. We have to use order of operations in reverse. So instead of plus 13, the opposite inverse would be to subtract 13. Move all the way over to the other side of the equal sign and subtract 13 there as well. 13 minus 13, that gives us the 0 that we were looking for, so we're left with our 3x equals, and 22 minus 13 is 9. And now we're back to a one-step equation. 3 and the x side by side here, that means multiplication. You can put a dot there if you want to. 3 times x, so the inverse operation would be to divide by 3. 3 divided by 3 does not give you 0, it gives you 1. You don't want 0x, that means you lose your x completely. We want 1x left over. 3 divided by 3 is 1. And that 1x equals 3. 9 divided by 3 gives us 3. So there's our answer. Now, one thing we haven't actually discussed in any of the other videos, and now that we're getting into more difficult equations would be really good practice, is to actually check our solution. And this is going to be very useful to you pretty much from here on out. But when we get into much more difficult concepts, especially solving inequalities, when we start looking at systems of equations, solving by graphing, anything that's going, really anything from here on out, it's going to be real good practice for you to check your solution. Now, when we ask you to check your solution, unless we specify, we don't necessarily mean that you have to write every single thing down. But it's really good practice if you just kind of scratch it out and jot it down and make sure that the number that you have boxed in this case, is the correct answer. So what we're going to do for our check, this is our check. So we're going to take our original equation before we did anything to it, 5x plus 13 equals 2x plus 22. This is our original equation. And we're just going to plug in 3 everywhere we see an x. Now, as I plug in 3 for x, I'm going to put that in parentheses. So I want to make sure I realize that that's 5 times 3. This part is 2 times 3. So anytime you plug in a number for a variable, it's really good practice to put that number in parentheses. That'll come in handy later with negatives and squaring numbers, especially if you're going to use your calculator. So now in this problem, we just need to follow order of operations. And order of operations tells us to multiply first. So I'm going to do my 5 times 3, which gives me 15. I'm going to leave my plus 13 here, equals. On the other side, again, still following order of operations, I have 2 times 3, which is 6, and plus 22. And now, going back to the left-hand side here, I'm going to go ahead and finish out my addition here. 15 plus 13 gives me 28, equals 6 plus 22 also gives me 28. Since 28 does equal 28, we know that is a true solution, so we can say with confidence that x does equal 3. So what I would like for you to do is try this problem on your own. So write this down. 7k plus 2 equals 4k minus 10. So pause the video for just a moment and take a little bit to answer this one, solve this equation for k. Alright, hope you're coming back from solving this equation for k. Let's go ahead and take a look at this. If you feel comfortable with it, you can go ahead and move on and see if you got the right answer. If not, you really need to make sure you focus and pay attention to each step that I take here in solving this equation. Going with my suggestion on moving the smaller variable to the larger variable, I have a 4k and a 7k. If you need to highlight that, you need to always have your highlighter out. Maybe that would be very helpful to you to highlight the constant, or the linear terms, Positive 2 and negative 10 are your constants. 4k and 7k are your linear terms. Highlighting those maybe make it a little easier on you on identifying which one to move. But the 4 is obviously smaller than the 7, so the opposite of a positive 4k is a negative 4k. And of course, what I do to one side of my equation, I have to move to the other side and do the same thing. And of course, if you've got your linear terms highlighted there, it'll be a little bit easier to identify where you have to line things up. So now I have 7k minus 4k, and that leaves us with 3k plus 2 equals, this gives us 0, which is the purpose of subtracting 4k. But be very careful here. If you miss this, this might be one of the places you missed it. This is a negative 10 that I have left now. So when I come down here to write what's left on the right hand side here of the equal sign, I have to be very careful there. It is a negative 10. Alright, now you're down to a two-step equation. So with this two-step equation, the opposite or inverse of adding 2 is subtracting 2. 3k equals negative 12. Negative 10 minus 2. So be very careful if you're typing that in your calculator. Negative 10 minus 2. And then the opposite or inverse of multiplying by 3 would be dividing by 3. 3 divided by 3 is 1, so I'm left with my 1k equals, and negative 12 divided by 3 is negative 4. So hopefully you got negative 4 when you tried this problem. If you plug negative 4 back into your original equation up here, if we go back to this original equation, and in place of k, I plug in negative 4. This is our check here. And again, if you didn't write your check, that's okay, but you really do need to at least enter these numbers in the calculator and double check yourself just to make sure you're always correct before ever moving on to the next concept, or just to help you out when you get to a test and make sure that you are picking the right multiple choice answer. So let's go ahead and simplify this. We have 7 times negative 4. Following our order of operations, we have to do the multiplication first. So 7 times negative 4 is negative 28. And I'm going to leave my plus 2 here. Move over to the other side of my equal sign, and I have 4 times negative 4, which is why it's very important to use parentheses so you don't think that's 4 minus 4. It's 4 times negative 4, which is going to give us negative 16 minus 10. And now we'll go ahead back on the left hand side here and finish this out. Negative 28 plus 2 is negative 26. And then on the right hand side, negative 16 minus 10. If you're down 16, you go down 10 more, then you're down a total of 26. So since negative 26 is equal to negative 26, we are certain that k does equal negative 4. The next video will be on solving equations with variables on both sides, but we will be taking a look at a couple of word problems.